Hello and welcome everyone to this video tutorial for chapter work and energy. But power is also a topic, so I have included power there also. So that is chapter number 11, work and energy. So when we are dealing with this chapter, work and energy, what actually we are doing is, previously we have already studied motion, force, gravity. We have already studied these things. We have studied motion, force and gravity. We knew, we are aware about initial and final, that is motion, that is U and V. We are aware about F, what are the laws behind F, how things work with the terms of force and how things will happen, behave when force is applied. Okay, so also we have dealt with the gravity, that something if is falling, it will fall down, and it is because of gravity. So, but what about other things which are related to it? Suppose in terms of force, I simply said that by applying force I am able to move this book from here to here, or by applying force a small child is able to drag his car from one place to another. So what are they doing? Force is getting applied. Motion is there. There is no role of gravity in these two. What is happening here? The thing sorry. The thing which is happening here or acting here is work. The thing which is acting here is work. So why I am telling this work is here, because when we are dealing with motion, we said that it can have final velocity, it can have final velocity, initial velocity. It must have started from where it has stops at some point. Okay, so if a thing is starting and moving, it is moving only because of force. It can move only because of force. So if it is moving and it is moving because of force, then it is doing some work also. Why do we forget it? If a bus is taking passengers from one place to second location, it is doing some work. Okay, so that is the reason a new topic, new situation was arise about work. That what if we join force with motion? What if we join force with motion? But force with motion is already joined in previous chapters. So, to study it in a much better way, a new concept was generated, or I should say, which was included. That is work. So, the definition of work is not from your day-to-day life. The definition of work is not from your day-to-day life. That if you are performing some work, if you are eating, then you are doing some work. If you are writing, you are doing some work. No. That is the, you can say, generalized definition of work. When we are dealing with scientifically or according to science, if work is done, then work can only be done if there is some force acting on an object which shows some displacement or which moves. Suppose if I start pushing this wall, if I am pushing this wall, no matter how much force I am applying, will this wall move? No, it will not move. So, because there is no displacement, there is no work done. Yes, I lost a huge amount of energy, but work is not done here. Okay? In a similar manner, if I kick a football, or if I pass a basketball to some other person, I applied force on that object. When I am kicking the football, I am applying force on the football, and because of the force, that football is able to move. It is able to cover some distance. Or if I am throwing a basketball, then I am applying energy from my hand, and I should say I am applying force from my hand, and that force is getting converted into, that force is getting making the ball to move or to cover a certain distance. So that is work done. So the formula for work done which we have here is W is equal to F into S. That is work done is equal to force into displacement. Force into displacement. That is the very basic thing about work. The work done is equal to force into displacement. Whatever be the force, applied on an object, the displacement it has shown, it will state that work is done. Suppose, like for example, I give you an example that I am applying force on this wall, but this wall is not moving. So displacement is 0. So in that manner, my work done is also 0. Now, suppose if there is a situation where thing is able to move a distance, but there is no force active on it. Thing is, suppose in universe, if an object is moving without any gravity or without any force, it is just moving. So it is able to cover a distance, but it is showing displacement, but it is not having any force. So at that moment, my force is 0. So my work done will also be 0. If I say, for example, a moving car is there and immediately brakes are applied, so it will retard or it will come to a halt, it will stop, it will try to stop. When the car is stopping, at that moment the force is applied opposite to the direction of force. Force is applied opposite to the direction of force. So, so it will be minus S. Or you can say minus F into S. At this moment, we can state that work done can be negative also. Work done is negative also. If the force is applied in the same direction, that is the direction of motion, work done will be positive. And if in the opposite direction, that is exactly 180 degree apart. 180 degree apart, then it will be a negative work done. In certain books, reflection books or lab books, you will find W is equal to F into S cos theta. Need not worry, this cos theta is right from our syllabus. That much degree knowledge is not there because this trigonometry will come in your syllabus from 10th class. So right now you only need to understand that this cos is only making an angle with the object. Force is making an angle with the object. Okay. So I simply said that when we are dealing with force which is exactly opposite to the direction, it will be a negative work. Okay. Now there are examples. There are certain examples. Like for example, if I took this book, take it and I place it here. So previously it was at that location, now it is at this location, and some work is done on the book. A force is applied and it is moved from one place to another. At this situation, I simply can say work is done. Work is done. Okay, so when we are dealing with work done, there are few points which you should study from the book also. That is on page number 147 after the unit example. That consider a situation in which the force and the displacement are in the same direction. The baby pulling a toy ball. Please go through this concept and you will be able to understand it very clearly. Whatever I have said is directly same to the things which are written inside the NCERT. Okay, so after work done, the next thing which we should understand here is energy. But before moving to energy, we should know about its unit because in physics, unit is very important. So when we are stating force, so if I say 1 Newton, okay, if force of 1 Newton is applied and the displacement is 1 meter, the displacement is 1 meter. The unit will become Newton meter. The unit will become Newton meter, or we also say it by the name of joules. We also there is another unit for it, that is joules. Okay, so if 1 Newton force is applied and the displacement was 1 meter, the unit will be Newton meter, or we can say joules. So that's, you have heard about joules, kilojoules. So it will keep on increasing, or whatever it is according to the situation. Now moving next, the next topic which we have here is energy. So when we are dealing with energy, when we are talking about energy, in market you are having a huge amount of energy drinks. In market you are having a huge amount of energy drinks. What do you think they actually do? They increase the sugar level inside our body, or they give they add extra things like lemonade. When you are thirsty, you drink ORS type situation. Take ORS type liquids, that is lemon, sugar, and salt, to increase the metabolism of your body. What actually happens here? They gives you the energy, because when they are used inside our body, energy is created. Okay, so when we are dealing with energy, it is, you can say simply, the ability to do work. Ability to do work. Previously you were tired, you were not able to move, but when you drank those things, your metabolism got a little bit of boost up, and now you are able to do, okay, now we can do something. For example, you are hungry, you are not able to do anything, you ate food, and now because of the food energy which your body take from the food, now you are able to do a number of things. So that is energy. Okay, or a simple definition I should say for energy would be the ability to do work. Energy is simply ability to do work. But when we are dealing with energy, we should understand energy can neither be created nor be destroyed. It can't be created, it can't be destroyed. It can only be transferred from one form to another form. For example, I am riding a cycle. So when I am riding a cycle, what actually happening is, because of my food which I have taken, the chemical energy of food changed into the physical energy. Muscular energy. Chemical energy to muscular energy, then muscular to kinetic energy. That is the cycle which is happening, because of the paddles which are moving, and you can increase or decrease speed whatever you wish to like. So this is the way how energy works. Energy can't be created, can't be destroyed, it can only be transferred from one form to another. For example, in dams, what happens is that the stored energy of water, that is potential energy of water, is used or utilized to move a rotor. Okay, so what will happen? Water at high level will be thrown on paddles of a wheel. That paddles will start on moving. You will get a mechanical energy, potential energy getting converted into mechanical energy. That mechanical energy will generate electrical energy. That electrical energy will be again transferred and will be used to draw a motor, which will again use that electrical energy to be converted into mechanical energy, and hence some work will be done using that motor. So all these are examples of energy. Again, I am stating energy can't be created nor be destroyed. Okay. So when we are dealing with energy, we are actually dealing with few things. We are actually dealing with few things. The basic two types of energy which you should study in this chapter are Ke and Pe. That is kinetic energy and potential energy. when we are talking about kinetic energy, we should know that kinetic energy is the energy of any moving object. Whenever an object is moving, it is supposed to have kinetic energy. Okay, kinetic means movement. Kinetic word example, the meaning of the word kinetic is motion. Okay, so whenever thing is in motion, the energy it possesses is kinetic energy. Kinetic energy, the formula of kinetic energy is can be derived very easily from the third equation of motion. Okay, that is v square minus u square is equal to 2as. Okay, so when we are talking about work, its formula is F into S. Its formula is F into S. In terms of F, I know in place of F, remember Jayamata MA, F is equal to MA. So F is equal to MA. I will write simply here W is equal to MA into S. But if I use this formula and if I take out the value of S, then V square minus U square upon 2A equals to S. Placing this value here. Placing this value here, what did we make now? W is equal to MA V square minus U square upon V square minus U square upon 2A and close. But A is also here, A is also here. So what we have? Both get cancelled out. So what we receive here is W is equal to M V square minus U square upon 2. So because it's a 2, it's I can take it as a common. What I will receive here is W half is equal to half M U square minus V square minus U square. But suppose if there is a situation that the vehicle, whatever the vehicle was, it started from rest. It was initially at rest, and suppose a football, it was initially at rest. I kicked it, and now it started moving. So initially it was at rest, so it should be 0. U should be 0 in that situation. Then W is equal to half mv square, and this is the formula for work kinetic energy. The work done by the kinetic energy or the kinetic energy can be calculated using this formula, half mv square. On your in your NCERT book, this derivation is provided to you on page number 151. Study it, and trust me, it's very easy. It's very easy. You will be able to understand it within a few seconds. Okay, only what is done? First formula, second formula, and third formula. These three are used, and some manipulations are there, and you will get the formula of kinetic energy. So this is the way how we calculate kinetic energy. And suppose if there is a situation in which U and V both are provided, then you will simply place the values in U and V, and you will be able to calculate it, because mass is not going to change. M is mass, and mass is not going to change. Whatever the object, if I am kicking the football, that doesn't mean football is going to lose its mass. Okay, if a bus is moving, that bus is not going to change its mass. Okay, so this is the way how we will be calculating the body. Now, when we are dealing with potential energy, so when we are talking about kinetic energy is only about motion. Kinetic energy is only about motion, and it ends with motion. It has nothing to do with any other thing. But when we are dealing with potential energy can be possessed by multiple objects in multiple ways. For example, if you take a bow and arrow, the moment you stretch you can say potential energy, the stretch, because of the stretch, a huge amount of potential energy got generated inside it. Now when you just release the arrow, that whole of the energy which was on that string will be transferred onto the arrow in form of kinetic energy, and it will start on moving. Similarly, if you take a spring and you just squeeze it, because of the squeezing, the spring will come near. At this moment, you are generating potential energy inside it, and this potential energy can be used at any points. A water at high level, in high tanks, they have potential energy. So anything which is at a rest can have potential energy. Anything which is at rest can have potential energy, and it depends upon its height. It depends upon its height from the ground. So generally the formula which is derived for potential energy is equal to mgh. The formula which is used for potential energy is mgh. Now when we are talking about mgh, why g? Why g? Because we are talking about height. I just said that there is water when kept in a tank at a height. So height, if there is height related, then it has something to do with the gravity and acceleration of gravity. Acceleration of gravity will be used here. So it will be mgh. Okay. Now when we are dealing with this mgh situation and this kinetic energy situation, okay, whenever you are getting a diagram on mgh situation, make sure you are using GS 9.8. You will be using GS 9.8. You will be using G only 10 when it is provided in the question. If the authors say that use GS 10, then you are allowed to use it. Else, if they are asking for G, then you have to use value of 9.8, which is called Earth. I hope you remember it from the chapter gravity. Okay, the next topic which we have here is conservation of energy. So when we are dealing with conservation of energy, again and again repeatedly say, मैंने बार-बार बोला, I have said it repeatedly that energy can't be created, can't be destroyed. It can only be transferred from one form to another form. It can only be transferred. So if I generalize this thing, so I should say that if I add, if there was something was having initially potential energy, now it is having, it got converted into kinetic energy. So then the sum of both of the energy should be constant. That is P and K, sum of potential energy and kinetic energy should be constant. That is the whole scenario, that is the whole concept according to the, if I say that conservation of energy, or if I follow the law of conservation of energy. Now, this is the proof that yes, it will always be constant. So, how to state that, how to prove this? Just imagine a situation. Just imagine a situation where a ball is is at a certain height. A ball is at a certain height. From that height, that ball was just left to free fall under gravity. So there are three situations I have here. First, when it was at its height, at point B, it has covered some distance. At point B, it has covered some distance, and at C is at it when it touches the ground. C is when it touches the ground. So, according to the this small diagram, what I can provide here is height. This is the height of when it was at a certain height. So, from reaching from A to B, it should have covered certain distance. कुछ तो distance cover किया, so because of the movement of that distance, it has covered some place. So let it be x. and remaining would be h minus x. Okay, using these things I am able to create this derivation. So what I have done is, at point A, P plus A is equal to constant, potential energy plus kinetic energy is constant. So mgh, that is the formula of potential energy, plus half mv square, that is the formula for kinetic energy, it should be constant. But because at a point A the ball is at rest, at point A the ball is at rest, so it is not at all moving. As the ball is not moving, so velocity is 0, and because of it this whole term will be 0. So the constant is mgh. mgh, I have only one value here. Now talking about point B, at point B it has covered some distance x. When it started falling, it has covered some distance x, and now it is at point B. So again, when I talk about mg, now its height is at this point, at point B, height is whatever with this x minus complete h. So that is the reason I have written h minus x. H is the complete height. This is the distance which is already covered. So to calculate this distance, what I can write? H minus x. So mg h minus x. Okay, now for kinetic energy, how I got this mgx? For this, just go through this equation. Third equation, v square minus u square is equal to 2gx. X is the distance which is covered. X is the distance which is covered by h. So 2gx, where because u is equal to 0, because initial velocity is 0. So u is equal to 0. Placing the value v square is equal to 2gx in kinetic energy formula, I will receive this. If we remove 2 and 2, then I will only get mgx. So mgx. Now, if I will open this bracket, so I will receive mgh minus sign mgx plus mgx. Both are cancelled out. I only have a single constant. I have a single constant. Previously also I was having this value. Now also I have this value. Energy is same. Okay, I will look at the third point. At point C. At point C, now ball has touched the surface. Now, because ball is at the surface, so its potential energy is 0, because height is 0. As there is no height, so there is no height, so there is no potential energy. But how kinetic energy becomes mgh? Just for this formula. V square minus 0 is equal to 2gh. You already know, because it was initially 0. Initially it started from where it started, it's 0. So now it has covered a complete height, complete distance, and that distance is h. So that's why 2gh. Now v square is equal to 2gh. Placing this value here, they both got cancelled out. I have only this thing remaining. So at point C also I only received mgh. So whatever is the situation, I will only have a constant value. Okay, so that is the way, or that is the reason we can say energy is conserved, or this whole derivation support the idea that conservation of energy is there, that energy can't be destroyed, it can only be transferred from one form to another, or the sum total of the energy is constant. Okay. A quick recap which we have already studied. Work done. Work done is F into S, that is force into displacement. Kinetic energy is equal to half mv square. Potential energy is equal to mass into gravitational and that is height mgh. Now, when we are having energy and when we are having work, suppose some person are able, or some things or some machines are able to do some work in a very high pace, in a very high speed. Okay, and same work or other hand is done by some other machines at a very slow speed. Suppose just a general example, you have seen government offices, those hammer or dot printer, matrix printer. They took a huge amount of time in printing, and the same machine, same work is done through photocopy machines. They give out the pages in fraction of seconds. So work is done in both situations, but one is able to do it in quite fast manner, and another is able to do it in quite slow manner. So what is the thing which is variable here? Both are machines. The variable is time. The variable is time, because it is the time which is deciding who is doing it fast and who is doing it slow. So when we are dealing with power simply means rate of doing work. Rate of doing work. So I told you time is a variable in performing work. So the formula will become W by T, that is work done upon T. So simplifying it, I can write here as F into S upon T. Or for the simplification, I can write MAS or GH upon T as per the situation which is there. Okay, whatever is used. If MA is there, then it will be there. Or if MG or whatever situation is arise according to it. Okay, so this is the only thing which you need to know about power. And do study the units which are provided in the NCERT book. Okay, units related to the power. That's all for today. Thank you.